Welcome everyone. Our Unit 10 mini lesson this week is going to be a little quiz prep. You may be asked to evaluate a factorial. A factorial is a function that multiplies a number by every number below it, all the way down to 1. So to evaluate something like 6 factorial, that means we multiply 6 by every number below it down to 1. So 6 factorial equals 6 times 5 times 4 times 3 times 2 times 1. And you can do that on your calculator, or you can do that using Excel. There's a factorial function. I think it's fact. And so you can do it a variety of ways, but you can even do it by hand. But we should come up with 720, okay? 3 factorial would be 3 times 2 times 1, which would be 6. So you can see just the jump from 3 factorial to 6 factorial is pretty massive. So you may want the calculator depending on the number you're given. In which one of the following scenarios would you use a combination to find the solution? So here we're comparing a combination versus a permutation. Remember that combination means order does not matter, whereas a permutation means the order does matter. So look at the following. In how many ways can the first, second, and third place ribbons be chosen from a group of 15 athletes? Think about, does the order matter here? Does it matter who we give the first place ribbon to or the second place ribbon to? How many different committees of 4 people can be formed from a pool of 20 people? How many kinds of 3-topping pizzas can be created from a selection of 12 different pizza toppings? And finally, how many unique 4-digit locker codes with no repeating digits can be created from the digits 0 through 9? So on the next slide, I have our answer. But take a minute and see which one you'd pick where the order does not matter. It doesn't change. It doesn't have any effect on it. The answer is how many different committees of 4 people can be formed from a pool of 20 people. It doesn't matter as long as you group the 4, which 4 people, because it is not set up such that you have a vice president or a president, a secretary, things like that. So it's just any 4 people. How many groups of those can we gather? Which one of the following is a pair of mutually exclusive events? Remember that mutually exclusive events are 2 events that cannot both happen. Event A, draw a heart from a standard deck of cards. Draw a diamond from a standard deck of cards. So in one draw of the standard deck, is it possible to draw 1 card and have it be both a heart and a diamond? The second option, going to New York City for your next vacation, traveling by car for your next vacation. What you want to ask yourself is it possible to go to New York City for your next vacation and also travel by car for that vacation? Event A, purchase a black vehicle. Event B, purchase an SUV. Is it possible to purchase a black vehicle that is also an SUV? Event A, draw a jack from a standard deck of cards. Event B, draw a club from a standard deck of cards. So in one draw of a standard deck of cards, is it possible to draw a jack and a club at the same time? So only one option of these 4 is mutually exclusive. And the answer is event A, draw a heart from a standard deck of cards, and event B, draw a diamond from a standard deck of cards. So if you draw 1 card from a deck, it is not possible that that one single card is both a heart and a diamond. It has to be one or the other, right? If you are asked to draw from a standard deck of cards, what is the probability that you choose a 7? So a standard deck of cards contains 52 cards, 13 of each suit. So 13 hearts, 13 diamonds, 13 spades, 13 clubs. There are 4 sevens in a standard deck of 52 cards, right? Because there's a 7 of hearts, 7 of diamonds, 7 of spades, 7 of clubs. So we actually have 4 cards that meet our criteria out of the 52. So we get 4 over 52, which we can simplify down or reduce down to 1/13. What is the probability of choosing a green marble from a bag filled with 6 blue marbles, 10 red marbles, 8 green marbles, and 4 orange marbles? So it's important to first figure out how many marbles we have in total. So we're going to add all of our blue, red, green, and orange. So we have 6 plus 10 plus 8 plus 4 gives us 28 total marbles. And of those 28 total marbles, we know that 8 are green. So 8 over 28 can reduce down to 2/7, and that's our probability of choosing a green marble from a bag containing those 28 marbles when we know there are 8 green. You are purchasing a new car. The maker offers 3 different models, and each model comes in 4 different colors: red, black, blue, and green. How many different options are available to you? So over on the left side, I've shown the 3 different models. And maybe there's just, better tires on one or a different interior on one, but we've all probably seen, a particular car in a different model style. And of course, we've all seen a particular car just in a different color. So when you're going to make this purchase, you actually have 3 choices for the model and 4 choices for the color. So I've drawn a tree diagram to the left and shown for each of the 3 models, I have 4 color choices, and thus in total, I have 12 different options available to me. And so we can draw out the tree diagram, or we can take the 3 times the 4, right? 3 different models, and for each model, 4 different colors. So we can also just multiply those numbers together to get our total number of options. So we have 12 options here. If the probability of an event happening is 5/36, what are the odds in favor of that event happening? So first, let's try to figure out, what does a probability of 5/36 mean? 5/36 means there are 5 favorable outcomes out of 36 total outcomes or possible outcomes. If 5 are favorable, it follows that 31 outcomes are not favorable. So if we're finding odds in favor of an event, the odds of an event occurring are equal to the ratio of favorable outcomes to unfavorable outcomes. And the directions say to use a colon to represent our odds, and to not have any spaces in between the numbers. So if 5 are favorable, 31 are unfavorable, our odds in favor, we list the 5 first and then the 31. So we have 5:31. If you toss a fair coin 2 times in a row, what is the probability that it lands on tails both times? So we know that each roll has a 50% chance, right? 1/2 chance of landing on tails. So you find the probability of the first roll, or the first flip, and then you find the probability of doing it again. So probability of tails times probability of tails. 1/2 times 1/2 equals 1/4. Which one of the following is an example of independent events? Our first set, event A, drawing a queen from a standard deck of cards. Event B, drawing a second queen without replacing the first card. Second set, event A, your first marble from a bag is red. Event B, your second marble from that same bag is red. Third set, rolling a sum of 12 with a pair of dice. Event B, drawing a diamond from a standard deck of cards. In the fourth set, Event A, boarding a plane first. Event B, finding a good seat. So which of these events, or set of events, are independent? Independent means that performing the first event has no effect on the probabilities associated with the second event. So if we draw a queen from the standard deck of cards and then we want to draw a second queen without replacing that first queen, are those independent events? No, because when we've taken that first queen out, we've changed the probability of drawing a second queen. In the second option, if you draw a marble out from a bag and it's red, and your second marble from that same bag, and I should have stated without replacement, similar to the card example above, it would not be independent because now you have one less marble that's red because you already drew that out. So the first two examples are both dependent events. The second event is dependent on the first, right? The probability changes because of what happened in the first event. In the third option here, rolling a sum of 12 with a pair of dice and then drawing a diamond from a standard deck of cards. Here we can easily see that these are two separate events. One does not have any effect on the probabilities associated with the second event. So this definitely is an example of independent events. And I think we all can agree that finding a good seat depends on boarding that plane very early or first, right? We've probably all boarded last to near last, and you got the worst seats in the house. So those are definitely event A and B here are definitely dependent. I walked through the 4 different scenarios on the previous slide. Here I've just highlighted the correct choice. So I know this can be a little bit confusing. Read these over and just make sure you understand the difference between independent events and dependent events. And let me know if you have questions on that. Venn diagrams represent relationships between sets. In a Venn diagram, which one of the following shaded regions represents the intersection of event A and event B? So we have 4 choices of Venn diagrams on the left. And the very first choice is our correct choice because this shows the intersection, what's common between event A and event B. So each circle is going to represent one of the events. And in the first drawing, that's the middle part is shaded, which shows what's common between event A and event B. In the second choice, this would only be event A, only one circle shaded. In the third choice, neither event A or B is shaded, and only the complements of those two events, what's not an A and B, would be shaded. And then the last one would be the union of events A and B, and that means any element in event A or in event B or in both. And so the union's pretty much either or both. The intersection is only what's common between the two events. Remember, you have 2 attempts on the Unit 10 quiz, and I will take the highest score. So take it once, review what you've missed, ask me if you have questions, and then take it again. The quiz is due Tuesday night at 11:59 p.m. Good luck, everyone.